Again, you're welcome to Waidsum Academy. Today we'll be looking at physics paper 2, multiple choice extended. Okay, we have paper 1, which is for core students. Extended is for those who are science students. So they have to take extended. So we're looking at May, June 2018, paper 2-1, and you just have 45 minutes. We have 45 minutes and for 40 multiple choice question, which means we have a minute for a question, and afterwards the remaining 5 minutes to do revision. Okay, in the first question, say a length of cutting is measured between 2 points on a ruler. Okay, so you see where the cotton started from 2.4. This is 2.5. This long one is 2.5. So a point before it is 2.4. Okay, this point is 2.4. This place 2.4. So we write down 2.4. The beginning one 2.4. Here we have 50.5, 50.6. So we have 50.6. So we have to find the we have 15. We have 50.6. We have to find the difference. Okay, 50.6 minus 2.4. Minus 2.4. So we have to subtract 2.4. That will give us minus 2.4. So we get 2. We have 13.2. 13.2. We have 13.2. Okay, that's the length of the cotton from the beginning here to the end here. You don't just write the value 50.6 like you have 50.6 in the option. You don't just do that. Okay, you don't just come and say, oh, because the end mark is 50.6 and you come and shade D. No, you have to subtract because it didn't start from 0. If it had started from 0, yes, the answer would have been 50.6. But it started from 2.4, so you have to subtract. You have to subtract this first 2.4 away from the whole length. Then you get 30.2. Now, we continue the question. Say, when the length of the cutter is wound closely around a pen, it goes round 6 times. This 30.2 centimeter, when you wound it round the pen, it goes round it for about 6 times. Okay, look at it. This length of cotton, you use it to wound it around the pen. It goes around this 6 times. What is the distance? What is the distance once round the pen? Once round, meaning if you go round once. So what will be the distance? The distance will be this 30.2 divided by 6 because it goes around 6 times. To get what it will be, you have to say 30.2 to get one round. You say 30.2 divided by 6. 30.2 divided by 6. Take the answer will give us 2.2. To give us 2.2. Okay? So our answer will be 2.2 centimeter if you divide 30.6 by this. Okay? So that's for question 1. We go quickly to question 2. Okay? The exam, you have to be agile, you have to be fast, you have to be smart. Now when does an object fall vertically through the air reach terminal velocity? When does an object falling vertically through the air reaches a terminal velocity? Okay? When does an object falling vertically through the air reach terminal velocity? We all know this, right? When any object falls from the aeroplane or anything in the sky or falling through the air, it reaches a terminal velocity when the air resistance equal to the weight of the object. It reaches a terminal velocity when, so we look for that option. Acceleration and the object becomes negative, no. When the acceleration of the object is equal to gravity, no. When the air resistance equals to the weight, yes. when the air resistance equal to the weight. This is exactly what we're saying for the sake of learning, not for the sake of, if it's the sake of exam, we'll quickly go to the next question. For the sake of learning, let's say this is an object falling through the air. Okay, if this is an object falling through the air, okay, so at some point, the terminal velocity is reached when the air resistance is equal to the weight. When the air resistance of the object equal to the weight of the object, when they are both equal. When the air resistance is equal to the weight of the object. When the air resistance is equal to the weight. When they are equal. So when these two are equal, this is air resistance. So I write air. I write air here. And this is a weight. We write air here. Then here is weight. Weight of the object. So when they are equal, it is when they are equal that we say terminal velocity is reached. And when you reach your terminal velocity, you have to open your parachute. You have to open your parachute. Okay, we'll go to the next question for the sake of saving time. Now, question number 3. Question number 3. Okay. Question number 3. Are we together? Question number 3. Now, let's see what we have in question number 3. Question number 3 says, a car is moving along a straight level roads with a constant acceleration. With a constant acceleration. A car is moving along a straight level road with a constant acceleration. Which graph shows the motion of the car? Which graph shows the motion of the car? Okay, when you talk about acceleration, distance over time is not acceleration. Distance over time is speed. So A is wrong. A is wrong. A is wrong. Okay, so this is wrong. Distance over time is also wrong when you are talking about acceleration. B is wrong. So the graph should be speed against time. And if you say this is a constant speed, so it has no acceleration. You know, when you are moving at a constant speed, you don't have acceleration. Acceleration is when your speed is increasing. So it means it's D. The answer is D. When your speed is increasing, that's when you have an acceleration. When your speed is increasing, that's when we have acceleration. We'll go to the next question. Okay, because you have to be fast in the exam and be accurate. You have to be fast and accurate. Question number 4, we say diagram 1 shows a beam balance. You can see a beam balance here in diagram 1. You see the pivot. This is a beam balance. This one is sitting on the pivot. Okay. Now a beaker with a wire loop balances the standard mass. We have a standard mass here. Okay. And then we have a beaker with a wire loop attached here. A beaker with a wire loop attached here, and we have the standard mass here. Okay, so they balance each other. The beaker is then removed and hung from a spring. We remove the beaker, this one, we remove this beaker, and then we hung it on a spring. We come and put it, see the beaker inside here, we take it out, we hang it on this spring. We hang it on the spring. Now the spring extends 5 centimeters as in diagram 2. So the extension here is 5 centimeters. Now the experiment is repeated with the same apparatus on the moon, where the acceleration of free fall is less than on Earth. You know, in the moon, the acceleration of free fall is less than, is 1.6 Newton per kg, while on Earth is approximately 10 Newton per kg, which is 9.81 something. So approximately for IGCSE, we say 10 Newton per kg. So acceleration of free fall in the moon is way smaller than that on Earth. Now, what we have is, which statement describe what happens in the moon? A, the beam ballast is balanced and the spring extended by 5 centimeters. In the moon, no. B, the beam ballast is balanced and the spring extended by less than 5 centimeters. Yes, it will extend by less than 5 centimeters. Although it will be balanced, but this extension will be less than 5 centimeters in the moon. It will not be up to 5 centimeters. Because why? Because the weight of this one is smaller. The weight in the moon is smaller than the weight on Earth. The weight on Earth, it's a certain number, but when you take it to the moon, due to gravity, which is smaller, the weight will be smaller. So B looks correct, but we have to read all the options. Maybe there are more correct options. Now the right hand balance pan is higher and the spring is set by 5 centimeters. No, the right hand pan is is higher and the spring extended by less than 5? No. So B is the most correct answer. Okay? B is the most correct answer for this question. Okay, we move to question 5. Question 5, in the exam you have to be fast like this. Question 5, or faster than this, because in the exam you are not talking, you are not explaining anything to anyone. So you just read, put the answer, move to the next one. You have to beat the time. You don't beat the time, you always lose in the exam. An object always has a mass, but does not always have a weight. An object always has a mass, but does not always have a weight. You don't have a weight if there is no gravity. You don't have a weight if there is no gravitational field strength. Okay? So weight is a function. Why? Because weight is a function of what? Of gravity. After the mass of every object has a mass, but not so that everywhere you are you have a weight. Weight is due to gravitational field strength. Weight is due to G. Your mass multiplied by your G gives the weight. Now you say what must be present and acting on the mass for it to have a weight. What must be present and acting on a mass for it to have a weight is gravitational field strength, which is A, right? Number 5A. What must be present and acting on the mass for it to have a weight is G, is gravitational field strength. Okay? So that's it. We move to the next question. Question number 6. So a force acting on a moving ball causes its motion to change. A force acting on a moving ball causes its motion to change. This force stays constant. Okay, what makes the force produce a greater change in the motion of the ball? What makes it produce a greater change in the motion of the ball? A force acting on a moving ball causes its motion to change, right? Yes, whenever a force acts on a moving object, it will cause the motion to change, either to change direction or to slow it down or to increase it, whatever. It depends on how the force is acting on it or what kind of force is acting on it. Now, this force stays constant. What makes the force produce a greater change in the motion of the ball? 1. Decreasing the total mass of the ball. B. Increasing the temperature of the ball. C. Using a ball with a hollow center but the same mass. D. Using a different mass, different material for the ball so that it has a lower density but same mass. What makes the force produce a greater change in the motion of the ball? Decreasing the total mass of the ball. Number 6, I think, yes. Decreasing the total mass of the ball could be, right? Decreasing the total mass of the ball. Because look at it. He's saying a force is acting on a moving ball. A force acting on a moving ball causes its motion to change. Okay? So, because when you compress it, when the force hits it, at that point, the mass might change. Okay? This force stays constant. The force itself is constant. Now, what makes the force produce a greater change in this? By decreasing the total mass of the ball. Okay? So, we go to the next question. Question number 7. Question number 7, we say a balloon and a mass are attached to a rod that is pivoted at P. A balloon and a mass, look at the balloon here, and a mass are attached to a rod that is pivoted at P. This is the pivot. Okay? The balloon is filled with helium, a gas less dense than air, so that it applies an upward force on the rod. So this balloon, this is filled with helium gas. This helium gas is less dense than air, but it applies an upward force on the ball. Okay, this mass is causing it a downward force, right? Now the rod is horizontal and stationary. The rod is horizontal and stationary. Is horizontal and stationary. Which action causes the rod to rotate clockwise? Which action causes the rod to rotate clockwise? A. Move both the balloon and the mass 10 centimeters to the left. No. If we move this one to the left and this one to the left, it will rotate anti-clockwise. It will go anti-clockwise. So A is not the best option. B. Move both the balloon and the mass 10 centimeters to the right. Okay? So if we move this one closer to the right, 10 centimeters, and this one closer, this will no longer balance. It will cause clockwise rotation, rotation in this manner. It will cause a clockwise rotation like this. Okay? Why? Because this mass is now too close to pivot. It's now very close to pivot. So if you move it from 20 to 10, it's very close to pivot. It will be too close to pivot. It will be here. This mass will be here. So the effect will not equilibrate. Will not equilibrate this one, or like we move this one 10 point. This one will have a greater force here. This one, so this one will be able to move upward. So it will cause clockwise rotation. It will cause this type of turning, clockwise rotation. Cause this kind of clockwise rotation. So I think B looks great, but let's see C and D. Move both the balloon and the mass to 25 centimeter mark. 25 centimeter mark is here. Both of them, both in the same place. They don't have the same weight. So it will not happen. It will not happen that way. Okay? D, move the balloon to 20 centimeter mark and the mass to 30 centimeter mark. The balloon to 20 here and the mass to 30 here. No, it will cause anti-clockwise. That will cause anti-clockwise rotation. So I think the most suitable answer is B here. The most suitable answer here is B. Okay, we move to the question 8. Question 8 says a car is moving in a straight line on a level road. Its engine provides a forward force on the car. A car is moving in a straight line on a level road. Its engine provides a forward force on the car. A second force of equal size acts on the car due to resistive forces. Which statement describes what happens? The car changes direction. The car moves at a constant speed. The car slows down. The car speeds up. So what happened? A car is moving in a straight line on a level road. Its engine provides a forward force on the car. A second force of equal size act on the car due to resistive forces. So if this is our car, if this is our car, if this is our car, okay, pardon us, okay, for whatever we've drawn. Okay, if this is our car, if the force here, the force from the engine, the thrust, is being balanced by a resistive force. If it's being balanced by a resistive force, what will happen? If they are equal, the forces are equal. We say the car changes direction, no. The car moves at constant speed, yes. Meaning the car will no longer accelerate because the resistive force and the force from the engine, this is moving forward. This is forward direction, okay? If they are equal, the car will move at a constant speed. The car will move at a constant speed. You no longer move, you no longer accelerate. You no longer accelerate. Is that okay? Now, is it which expression gives the momentum of an object? Momentum is mass times velocity. Momentum will sometimes use a big P to note it. Momentum is mass times velocity, mv. Momentum is mv, mass multiplied by velocity. So we look for that has mass times acceleration. This is force, no. So this is a force. This is not momentum. Mass times gravitational field strength. This is weight. This is not momentum. Mass times velocity, yes. So momentum is mass times velocity. So we go for that option. Momentum. So you see, half times mass times velocity, this is kinetic energy. Velocity squared times mass times half, this is kinetic energy, Ke. So the answer is C. We go to question 10. Okay, as energy is transferred into different forms, it eventually becomes dissipated. What does it mean? As energy is transferred to different forms, it eventually becomes dissipated. Dissipated is like, you say the energy begin to spread out. It's like thermal energy. You begin to lose it to the surrounding. Okay, you begin to lose it to the surrounding. All the energy disappear, not the right physics word to say the word disappear. Let's see if we can find a better option. The energy finally changes into a very possible form of energy. This is too bogus. This claim is too bogus. It didn't narrow it down. Let's look for another option. The energy spreads out among the objects and their surrounding. This looks very close to the answer. The energy spreads out, that's dissipated. When you say dissipated, energy has spread out. and amongst the object and the surrounding. Then the D, the total amount of energy become less. No, that's not the point. So C is the answer here. C is the answer. The energy becomes what? Becomes spread out amongst the objects and the surrounding. Okay, we go to the next question. A ball of mass 1.2 kg, always we put the parameters out. 1.2, m equal to 1.2, m equal to 1.2. A ball of mass 1.2 kg, 1.2 kg, that's the mass, okay, 1.2 kg. A ball of mass 1.2 kg drop from a height of h is h, the height, okay, here's the answer for energy. Height of is dropped from a height of it dropped from a height of okay, sorry, let's move on. We say a ball of mass 1.2 kg is dropped from a height of 30 meters. So h is 30 meters. H is 30 meters. Okay? H is 30 meters. As it falls, 25% of the initial gravitational potential energy is transferred to thermal energy. Okay, first of all, let's calculate the gravitational potential energy. Okay, the gravitational potential energy, just permit me to write G, okay, GPE, gravitational potential energy, is equal to mgh. We know this, right? Is equal to what? mgh. The mass times gravity times mass times gravity times height. mgh. Mass times gravity times height. So the mass is what? 1.2. So we put 1.2. 1.2 times gravity, they will not give you, is a constant value. They will not give you the expect you know it. It may be at the beginning of the paper, the front page. They might put the value of gravity there. Okay, times 10. Gravity is 10 for IGCSE, you just use it for convenience, 10. Times, the height is 30. They've given us the height already, right? They've given us the height. The height is 30 meters. So we multiply this out, we get a certain value for our energy. We get a certain value for our energy. So what do we get? When we multiply this out, 360, right? This will give us 360. This will give us 360. Okay? Because 10 times 1.2 is 12. 12 times 3 is 36. And then this 0. So you get 360. Okay? Some questions you can do without pressing the calculator. You get 360 joules of energy. This is the initial gravitational potential. This is the gravitational potential energy just before the object was dropped. 25% of this energy of the initial gravitational potential is transferred to thermal energy. So we have to find 25% of 360. We have to find 25%. 25% means 25 over 100. And in fraction is 0.25, right? 25 over 100 is 0.25 in fraction. So you can simply say 0.25 times 360. 0.25 times 360. 0.25 multiplied by 360. Multiplied by 360. So we get a value. This value does not mean the answer. The value is the amount that is transferred to thermal energy. So 0.25 times 360, what do we get? 0.25 times 360, what do we get? But that's not what they are asking. They are asking what is the kinetic energy of the ball just before it hits the ground. So we have to see the thermal energy that is lost first. We have to subtract it away from the potential energy before we can get the kinetic energy. Okay? So what do we get? 90. So here we get 90 for the thermal energy. We get 90 for the thermal energy. So the thermal energy is 90. This is energy that is lost. The one that is lost to heat. The one that is lost to heat is 90 joules. Okay, 90 joules. Okay, but this is not your answer. You see, the way they catch you, they put 360. Some students will take 360. they put the 90. Some students will go for the 90. But that's not the question. The question is, did they ask you for the 25%? What's the 25% of energy that is lost to thermal? They didn't ask us to calculate the thermal energy. If they say the thermal energy, B would have been the correct answer. If they said the total gravitational potential energy, this would have been the correct answer. But they're asking for the kinetic energy just before it hits the ground. So the KE, kinetic energy, will be the gravitational potential energy minus the thermal energy that we lost. It will be the kinetic energy will be the gravitational potential energy. Okay, so I can just write potential energy, but it really means gravitational potential energy minus the thermal energy, thermal T energy, TH energy, minus the thermal energy. Okay, minus the thermal energy. So that will give us 360 minus 90. 360 minus 90 in maths. If you're a math student, you already know this is like you're subtracting 1 quadrant. So when you say 360 minus 90, you get 270. That will give us 270, right? That will be equal to 270. 270. So that's our answer. The kinetic energy is 270 joules. Kinetic energy is 270, which is this one, C. It's 270 joules. Okay, so that's that for this. We move on to the next question. This calculation used to waste time, so we move on. When you get to theory, you speed up because calculation question will take some of your time. A girl hangs by her hands from a bar in a gymnastic. She pulls herself up until her chin is level with the bar. The mass of the girl is 48. A girl hangs by her hands from a bar in a gymnastic. Okay, in a gymnastic. She hangs herself in a bar with her hands. She pulls herself up. She begins to pull herself up until her chin is level with the bar. Now the mass of the girl is 48, so they've given us the mass. She pulls herself up through a distance of 0.2. So since it's pulling herself up, it's h. This distance is a vertical distance, h. So we have m 48. We have m 48. So if in case they want the energy, gravitational energy is mgh. So we just multiply. And she does this in 2 seconds, and that means they want power. Once they give you time, they want power. What's the useful power she uses to pull herself up? Okay, before you can calculate power, you have to calculate energy, because power is energy divided by time. Power is energy divided by time. Power is energy over time. Energy over time. Power is energy over time. Power is energy over time. Okay, so we have to calculate the energy. Energy in this case is a gravitational potential energy, which will be calculated with this one, mgh. Okay, this is what we will use to calculate our energy. So our energy will be equal to this one. So we have to calculate the energy first before we can calculate the power. We have to find the energy first before we can find the power. Is that okay? Okay. So here we just substitute the value. We can just, or we go straight. So we just say P, we go straight once and for all. We say P is equal to what's the energy? mgh. Mass is 48. So we put 48 multiplied by 48 multiplied by gravity, which is 10. Gravity is always 10, okay? Multiplied by height. The height they gave us was 0.25. So we multiply by 0.25. Multiply by 0.25. Okay, so if you multiply this by 10, it becomes 2.5. 2.5 times 48. 2.5 times 48. Everything divided by the time. Time is 2 seconds. 2.5 times 48. So if you multiply everything divided by 2, you get 60. So which is C? 60 watt. The unit of power is watt, okay? 60 watt. So this becomes the answer to this question. We go to the next question. It says 4 identical beakers are filled with each volumes of liquids P or Q as shown. Liquid P is more dense than Q. Liquid P is here. Is more dense than liquid P is more dense than Q. At which point is the pressure the least? At which point is the pressure the least? Okay, the pressure will be on the least pressure. You know, pressure is depending on the density. Pressure is a function. Pressure in a liquid is depending on what? Which factor? Density. Rho GH. Rho is the density. Pressure depends on density. So if density is low or small, pressure will be small. Pressure in a liquid will be small. If the density is high, pressure will be high. So it's depending on height also. So since this one is a 4 identical beakers are filled with equal volumes of liquid P or Q as shown. Now liquid P is more dense than liquid Q. Liquid P is more dense. Okay? At what point is the pressure least? They want least pressure. If they want at what point is the pressure greatest, if that's what they wanted, we would have gone for A and B because it has a bigger density. We would have gone for option A and B because it has because pressure is depending on the density and the height. It's depending on the density of a substance and the height of the substance. So since they want the least pressure, we go to the option with the least density. The one with the less density. The less dense one is C and D. So out of this less dense one, we have to look at the one with the bigger height. Which one is the bigger height? D. So the answer, the solution is D to this one. Because it has what? A higher height. Because pressure is depending on density, and since you want least pressure, so you also need to consider this. Is that okay? So that's that for this option. We go to the next question. Question number 13. Yeah. Okay, we go to the next question. Question 14. An oil tank has a base of 2.5 meters square and is filled with oil to a depth of 1.2. You have an area of 2.5, and you have a height of 1.2. If you want volume, we can calculate volume. And then the density is this 800. So what is the force? First of all, pressure is force over area. So let's first of all make that one and make the force formula from here. We cross multiply to find the formula for the force. After that, we calculate the pressure. We already have what it takes to calculate the pressure from the question. So if you're looking for force, because they ask you what is the force exerted on the base of the tank. So we're looking for the force. So the force from here, if you cross multiply, force is pressure times the area. Force equal to pressure. Force equal to pressure times area, PA. Force equals to pressure times area. Remember, the question has given us the area. The only thing we need to calculate is the pressure. Once we know the pressure, look at the area, it's been given to us. And we have the density and we have the height. So we can calculate that pressure. Remember, pressure is rho GH. Pressure in a liquid, Okay, because this oil. Pressure in a liquid is real GH. Liquid and gas, we use this formula to calculate the pressure. So we say pressure in a liquid or gas can be calculated using real GH. Real GH. Something like E, but it's not E. Real GH. And it's actually density. It's actually density. So the density is 800. The density of the oil is 800. You must check the unit if they conform. Meter square, meter, kilogram, yes. So we use the 800. If they don't conform, you have to do conversion. Okay, that's the first thing you check. Okay, so we have 800. We have 800, which is the density, kilogram per meter cube. Okay, times the gravity, which is always 10. They will not give you, but you should know. Times 10. Then times the height, which is 1.2. Times the height, which is 1.2. So what is the pressure? What is the pressure? Times the height, which is 1.2. So what is the pressure? 800 times 10 times 1.2. What do we get? Okay, that's the pressure, right? Pressure will be 9,600. That's not your answer because that's not the force. 9,600. So they will go and put, they will go and put this in the option for you. Some student will just reach here and they will choose, oh, they see 9,600 here, they go and circle the answer. Remember, they did ask us to calculate the pressure. They want the force. Now you use pressure to multiply area in order to get the force. So this 9,600 multiplied by the area. Area is 2.5. Multiplied by 2.5. 9,600 multiplied by 2.5. What do you get? 9,600 multiplied by 2.5. What do we get?
24,000.
We get 24,000. This will give us 24,000. This will give us 24,000 Newton. Okay? Because this is what they want us to calculate the force, not the pressure. The force, 24,000 Newton. So we get 24,000 Newton. So the option is D, 24,000 Newton. This is the correct answer. Okay? So you see how it goes. Now we go to question 15. Question 15. It says when molecules of a gas rebound from a wall of a container, the wall experiences a pressure. When the molecule, when every time molecule hit the wall, it's like force over an area. It's like force over an area result because molecule exert a force on the wall and it hits a particular spot, that's an area. So that's pressure. That's pressure. Whenever this happens, we call it pressure. So we say this pressure is equal to force exerted by the molecule over an area. Force exerted, the molecule has exerted a force over an area, right? So we say this is FA, F over A. So what is the cause of this pressure? One of the causes of the pressure is the momentum, the change in momentum of the molecule. Okay, the molecule, they move zigzagly, randomly. They hit themselves, they hit the walls, they bounce off. So this cumulative effect of momentum, their change of momentum, result to pressure. Okay, A, the change in energy of the molecule, no. B, the change in momentum of the molecule, yes. C, change in power of the molecule, no. D, change in speed of the molecule, change in momentum. Anytime you see this type of question, you just go for change in momentum. Collision. When you see collision, we are talking about momentum. Okay, so we go to that. We go to the next one to save time because we spent a lot of time in calculation aspect of the question. Okay, a student wishes to calibrate a mercury in glass thermometer with a scale, degrees sensor scale. Which values? When you are using a degree sensor scale, we use the melting point of ice and the boiling point of water. anytime you're doing the degree sensor scale, when you do thermometer, okay? So when you're doing degree sensor, when you use the Kelvin scale, we just use the values in Kelvin. When you're doing degree sensor scale, the lower fixed point will be the melting point of ice, and the upper fixed point will be the boiling point of water. So what value should she use for the lower fixed point and for the upper fixed point? So the lower fixed point will be melting point of ice, boiling point of water. Yes, this one. This option is the most adequate. Because A says melting point of ice, boiling point of mercury, no. B says melting point of ice, boiling point of water, yes. If you are doing degree sensor calibration, this is what we do, okay? This is what you need. The melting point of ice for the lower fixed point of the thermometer. Like what we are saying here, if you draw a thermometer, what we are saying is, if you have a thermometer, if you have a thermometer like this, let's say this is a thermometer, okay? If this is a thermometer, you know you have different calibration. You have the lower fixed point, you have the upper fixed point. We are saying this upper fixed point is, you know, there's 100-degree divisions between the lower fixed point and the upper fixed point. This is 100, which is the boiling point of water. 100-degree Celsius, 100-degree Celsius, and this is 0 degrees Celsius, which is the melting point of ice. 0 degree Celsius, which is the melting point of ice. Okay, so just a little bit, so we can move on. So then the next question: which statements about boiling and about evaporation are both correct? Boiling is a fast process, evaporation is a slow process. Boiling produces bubble, evaporation does not produce bubble. Evaporation requires a wide surface area. Boiling does not necessarily need a wider surface area. You know at this point already. Okay, so let's find which one matches with this. Is it boiling takes place only at the surface? No, boiling does not only take place. It takes place throughout the liquid. So A is wrong. Boiling takes place only at the surface. So A and B is wrong because they say boiling takes place only at the surface. So for that alone, your answer is not in A and B. You look for your answer in B and C, in C and D. Is it takes place throughout the liquid? Yes. Boiling takes place throughout the liquid. Evaporation takes place only at the surface. Yeah, evaporation takes place only at the surface. Let's see the D. Takes place throughout the liquid for boiling. Takes place throughout the liquid. No, evaporation does not take place throughout the liquid. So the best answer, the most correct answer is option C. The most correct answer is option C. Okay, now we go to question 18. On a cold day, a metal front door knob X and a similar plastic knob are at the same temperature. Why does X feel cooler to touch than Y? Why does X feel cooler? Is the metal one, right? The metal one, why does it feel cooler to touch than Y? A says X converts thermal energy better than Y. B says X is a better thermal conductor than Y. B says X is a better thermal conductor than Y. C says X is a better insulator than Y. No. Anything insulator? No. X is a better radiator of thermal energy than Y. The answer is between A and between B and I think B and D. Okay, X is a better thermal conductor than Y. I think so. You know, metals are better conductors than what? Than plastic. Plastics are evil insulators. Okay, so for that reason, this option. Okay, we go to this question. Is a light travels at a speed of 2.0 2.0 will not be in air, meter times 10 to the power of 8 meters per second in a glass. Okay, in a glass. In the, because in air is 3.0. In the glass, the wavelength of the wavelength is, so they've given us speed of glass, they've given us the wavelength. You know, speed is lambda f. Speed, this is wave question, is lambda. Lambda means the wavelength multiplied by the frequency. Wavelength multiplied by frequency. So what they want from us, what is the frequency? So you make f the subject. They want the frequency, so make f the subject. So frequency is equal to the speed divided by lambda. Speed divided by lambda. Meaning divided by wavelength. Speed divided by wavelength. Okay? And the speed is 2 times 10. Even if I just say 0.0, it's same thing, okay? 2 times 10 to the power of 8. 2 multiplied by 10. 2 multiplied by 10 to the power of 8. 2 multiplied by 10 to the power of 8. Okay, that's the speed there. The lambda, the wavelength of the light is 4.0, which is 4. So you say 4. So this is 4. 4 times 10. 4 times 10 to the power of -7. Okay, -7. You see, this is indices. 10 to the power 7 divided by 10 to the power 8 divided by 10 to the power -7. So division in indices is minus. So minus is plus. So I'm going to add this and this together. Without calculator, I can do this. Add this and this together, I get 15. So divide this by this, I get 0.5. So what I have here, 2 divided by 4 is 1 over 2. And 1 over 2 is 0.5. So we have 0.5. We have 0.5 times 10 to the power of 15. 0.5 times 10. 0.5 times 10 to the power of 15. Okay, remember this is not the right way of leaving standard form. This is not the right way. You see, in standard form, this number here must be less than 10, but must be greater than or equal to 1. Cannot be in decimal. So I will move this decimal once to the right, I will reduce this one. If you move this decimal one time to the right, you have to decrease the power. If you move the decimal once to the right, this becomes 5. Instead of 0.5, it will become 5 or 5.0. This will become 5 multiplied by 5 multiplied by 10. 5 multiplied by 10 to the power of 14 hertz. You know, hertz is the unit of frequency. Oh, sorry. To the power of 14. Why is the power reduced to 14 from 15? Because we moved the decimal point one place. You studied standard form. We moved this decimal one time to the right. This one will reduce. Times 10 to the power of 14 hertz. Hertz is the unit of frequency. Hertz is the unit of frequency. Hertz is the unit of frequency. Is capital H, small letter Z. Okay, this is what it is. So the option is what? The option is there, this one. This is the correct answer. Okay, this is the correct answer. So we move to the next question. Which arrow on the graph shows the amplitude of the wave? Amplitude, B, right? Amplitude from the horizontal position to the peak of the wave. That's amplitude. Okay, so B. So this one we don't need to waste time because time is not against us. Time is against us. Time is not for us in the exam. Any question that is cheap, you quickly harvest it and put it in your bank account. So when I mean bank account, I'm not saying money bank account. Okay, now let's take a look at this. Scout P signals to Scout Q on the other side of a valley by using a mirror to reflect the sun's light. By using a mirror to reflect the sun's light. Okay, look at Scout P. Look at the light from the sun. Okay, so it's going to send it here to Scout Q. This is going to reflect this light to this place, because the light is obviously not coming here. So he wants to send this light here. But he needs a mirror to do that. So which mirror position allows the sun's light to be reflected to Scout Q? How will you position the mirror? The light is coming like this, obviously reflected like this. Okay, I think A is good. Let's look at B. B, if you make the mirror a bit like this, if you make it a bit like this, then the light will go somewhere else. C, if you make the mirror vertical, this ray comes to it. If the ray comes to it, then it will go this way. It will go this other side. If you make the position of the mirror to be like this. And then if you make the position of the mirror to be like D, D is like this. If you make the position of the mirror to be like this, the light will come down this way. Down this way. The light will not go to Scout Q. So the best way to receive the light at Q is A. Is positioning the mirror in as it is in A. When we position it like this as it is in A, Scout Q will get the light. Okay. Okay, a prism is made from a transparent plastic. In this plastic, light travels at 0.8 c, where c is its speed in air. Okay, light enters one face of the prism at right angle as shown. Light enters one face of the prism at right angle as shown. A prism is made from a transparent plastic. In this plastic, light travels at 0.8 c. So we can find the speed of light in the plastic by saying 0.8 times 3 times 10 to the power of if you say 0.8, if you use 0.8 to multiply 3, you get 2.4, right? You get to multiply 3. You know the speed of light in air is 3 times 10 to the power of 8. It's 3 times 10 to the power of 8, right? Speed of light. So they say speed in the plastic is 0.8 the speed multiplied by the c, multiplied by speed of light. So if we do this, I think we'll get 2.4. So the speed in the plastic is 2.4 times 10, 2.4 times 10 to the power of 8, times 10 to the power of 8. Now here we can find the refractive index. Okay, since we now know the speed in air and speed in glass. Refractive index is the speed in the air over speed in the medium. Speed in air, V air, speed in air over speed in the medium. V air over speed in the medium. So the medium is the plastic. So the speed in air is what? 3. So 3 times 10, okay, times 10 to the power of 8. 3 times 10 to the power of 8. 3 times 10 to the power of 8 over 2.4. So 3 divided by 2.4. 3 divided by 2.4.
No.
Okay. 2.4 times 10 to the power of 8. You know, 10 to the power of 8, we cancel 10 to the power of 8. So this one will give us, the refractive index will give us 1.2 1.25. 1.25. This is the refractive index. Okay, this is the refractive index. Now it says light enters one face of the prism at right angle as shown. Light comes here at right angle, one face of the prism. Okay. So this is 90 degree. And then it's refracted here. Say the light just escaped from the slopy face of the prism, this slopy face. What is the angle theta? What is angle theta? Here is 90, right? What is angle theta? Okay, so but we know that refractive index is equal to sine of the incident angle, sine I over sine R over sine R. Okay, so this will be 1.25 is equal to the incident angle is 90, right? 90 degree into the plastic. So sine 90. I think sine 90 is 1, right? Sine 90 over sine R. So let's find sine R first over sine R. So if you cross multiply, you get 90 sine R. So sine R equals to sine 90 divided by 1.25. Press sine 90. So sine R. Sine 90 is what? Sine R is
0.89. Sine 90 is 0.89.
What's sine 90? I think sine 90 is 1, right? This will be this multiplied by this equal to sine R will be, I have to make this one the subject, is equal to sine 90 over 125 to be sine 90. So sine 90 is 1. So I just go straight to 1 divided by 1.125. So 1 divided by 1.125, what do we get? 1 divided by 1.125. No, 1.25. It's not 1.125. This value, 1.25. 1 divided by 1.25.
0.8.
Check it. Can we check again? Sine R is equal to 0.8, right? Now, we find sine inverse of 0.8. What is the sine inverse of 0.8? R will be the sine inverse. R will be the sine inverse. Sine inverse of 0.8.
53.1.
So R equals to 53. R equal to 53. 53.1 is approximately 53 degree. So the answer is D, 53. R equal to 53. Is that okay? 53.1 is approximately 53. So R angle theta equals to 50. So it's 53. So that's our answer, okay, for this calculation. So we'll move on quickly. Okay, take note. First of all, we calculated the refractive index. We brought the refractive index to do the second law, the other law. You know, the law is refractive index is this, and refractive index is also sine I over sine R. That's just all we did, and we got our angle. Is that okay? So we'll move over to question. Okay. So we'll move to the next question, which says that the sun emits infrared radiation and light. The sun emits infrared radiation and light, and the light from the sun reaches the earth in 8 minutes. Which row gives the correct information about the infrared radiation? Which row gives the correct information about the infrared radiation? The wavelength of the infrared radiation and the time taken for the infrared radiation to reach is same 8 minutes. Same 8 minutes. So the wavelength of the infrared longer than the wavelength of light. Yeah, I think right. The infrared wavelength is bigger than that of longer than that of the light. Okay, but it takes the same 8 minutes. But the frequency of light is bigger than that of the infrared. Okay, so the answer option is A. For this, the option is A. We move quickly because we have less time. So a dolphin has a range of audible frequency of 150 Hz to 150,000 Hz. Remember, human is 20 to 20 kilohertz. 20 Hz for human is 20 Hz to 20,000 Hz. For human is 20 Hz for human is 20 Hz to 20,000 Hz. To 20,000. 20,000 means 20 kilohertz. Means 20 kilohertz. Okay, 20,000 Hz means 20 kilohertz. So you can just write 20 kilohertz. Okay, so for human, a dolphin has an audible frequency of 150 Hz to 150,000 kilohertz. Now, which range of frequencies can be heard by both the humans with good hearing and by the dolphins? Human with good hearing and dolphins. This is too small for dolphin, right? It's probably too small, right? Right? With 20 Hz to 150 kilohertz, human do not get to 150 kilohertz. So this cannot be suitable for human. Dolphin maybe yes. Dolphin is not even, don't go low as 20. Dolphins lower value is 150. So A is wrong for then 20 kilohertz to 150 kilohertz. Human, this is the highest for human. It doesn't even, human does not even get to 150 kilohertz of hearing. So this is not suitable. 150 Hz to 20 kilohertz, yes, because dolphin can hear 150 at its lowest value. We lowest value is 20 Hz. Dolphin's lowest value is, so we are both suitable here. Okay, and then dolphin can hear 20 kilohertz even beyond this. So human can still hear and dolphin can hear. So this, the best option here is this D. The best option for this question is D. Now we go to the next question. We go to the next question. Okay, question 25. We say a permanent magnet is placed close to a bar of soft iron. A permanent magnet is placed close to a bar of soft iron. So you can see the permanent magnet here is south, here is north. Okay, the soft iron bar. What are the polarities of the end of P and Q? Okay, if this could be close to this or attracted to this, it has to be what? South. So here has to be south. P has to be south. So anyone that starts with north is already wrong answer. So these two, they are already wrong, considered wrong. Okay, the option, it has to be south. South here and north here. So south, north. C is the most correct option. Okay, C is the most correct option for us in this, for this question. We'll move to the next one. A steel magnet is placed inside a coil of wire. A steel magnet is placed inside a coil of wire. Which method is used to demagnetize the magnet? If you want to demagnetize the magnet, you put it in an AC supply. You put it in an AC supply. Is that okay? So let's see which method is used to demagnetize the magnet. Say A, connect the coil to an AC power supply. Okay, connect the coils. B, connect the coils to an AC power supply and slowly remove the magnet from the coil. Yes, after you connect it to an AC, you slowly remove the magnet from the coil. Okay, connect the coil to a DC. No, anything DC is wrong. So these two wrong. In demagnetization, we don't connect to a DC if you want to demagnetize, unless you want to magnetize. If you are demagnetizing, you have to connect to an AC. So the best option is B, because you still have to remove the magnet from the coil. After you've connected to an AC supply, you remove in order to demagnetize. The next question is electromotive force EMF of a rechargeable battery 6 volts. What does this mean? If the electromotive force is 6 volts, we say it means 6 joules is maximum energy the battery can provide in 1 second. Let's see the B. 6 joules is the total energy the battery can provide before it has to be recharged. C. 6 joules of energy is provided by the battery to drive the charge of 1.0 yes around the complete circuit. I think this is most absolute, right? 6 joules of energy provided by the battery to drive a current. We say to drive a charge. A charge that is moving is what we call a current. Okay, but it is the charge that is driven around the circuit. So this option is most correct. Now we see this one. A student measures the potential difference across a device and a current in a device. Which calculation gives the resistance of the resistance is the potential difference, which is voltage divided by the current. Resistance is the potential difference divided by, remember, V equal to IR divided by the current. Resistance is the potential difference divided by the current. Because if you cross multiply, V equal to IR, current multiplied by. So if you are looking for resistance, it's the voltage divided by the current. So we look for the one, if you start with current divide, is wrong. It's not current divide, current. So A and B, absolutely wrong. This A and B, absolutely wrong. Because it's not current divide by potential difference. It is potential difference, which is voltage, divided by current. So C is the most absolute correct answer in this regard. So we move to the next one to save time, okay, for the sake of time. If you want to get it better, you pause the video and then you begin to figure it out, okay? Now let's move to the next one. Calculations always take time. A little bit more. A water heater is connected to a 230 voltage supply, and there is a current of 26 ampere in the heater. So we already know where we're going. It takes 20 minutes. These 20 minutes we have to convert to seconds to heat the water to the required temperature. How much energy? Energy is there. We've done this. You can check out our videos on this, okay? We've done this topic, electrical energy. We've done generator, motors, and all of these things. Okay, so energy is IVT. Energy is I, the current, multiplied by the voltage, multiplied by time. But in this regard, we have to change this time from minutes. If you take 20 minutes to calculate, you're going to fail. Okay, you're going to get the wrong answer. You're going to get the wrong answer. You have to change it to seconds because that's the proper unit. So change it 20 to seconds, 20 minutes to seconds to say 20 minutes multiplied by 60 seconds. To multiply by 60. If you want to change it to seconds, so you multiply by 60. This will give you 2 times 6 is 12. That's 1200, 1200. Okay, what you call 1200. Okay, in America, in US, we call it 1200. Call it 1200, which is 1200. Okay, so that's that. Okay, so you get, this is the seconds. This is the time, okay, it takes for the heater. So we substitute our value here. So our energy will be what now? Our energy will be what? Energy is equal to I, the current is what value? 26. So you say 26 multiplied by 26 multiplied by, okay, I always draw this something like this for multiplication, okay? Don't be confused. 26 multiplied by the voltage. The voltage is 230. So we say 26 multiplied by 230 multiplied by the time. The time is 120. T is 120 seconds. T is, sorry, not 120, 1200. T is 1200, 1200. Okay, so when we multiply all of this, what do we get? What do we get when we multiply this? We will get approximately 7 million, approximately 7,200,000 joules. So which is D, right? So we get our answer to be this D if you multiply. So you pause the video, multiply these values. 26 times 230 multiplied by 1,200. You get approximately 7 times 10 to the power of 6. You get this. Is that okay? So that's our answer. Now we go to the next one. Which electrical symbol represents a diode? Okay, this is a cell. This is a diode. This is a bulb. This is a light dependent. No, not light dependent. Light emitter, something like that. But this is the diode. Okay. Or you can say this is a variable resistor. This is a variable resistor. Sorry. This is a variable resistor. Okay, now, so our answer here is B, a diode. The symbol that represents a diode is this one. So this is our answer, question 30. Okay, we're moving, we're progressing. Remaining 10 questions, okay, for us to be done with this paper. A student set up this circuit. Here is a battery. Here is a buzzer. Here is a rheostat or a thermistor. What's the purpose of this circuit? To allow the lamp to be made dimmer and brighter. Is that the purpose of the circuit? To allow the lamp to be made dimmer and brighter? No. This is a buzzer. This is not for light. This is for buzzer is for sound. Buzzer is for sound. Buzzer is for sound. B, to amplify the sound of the voice. Okay, but there is a thermistor. So is it to amplify the sound where there is a thermistor? Because there must be, it must have something to do with temperature. To light a lamp in the dark. To sound a bell when the temperature rises. Yes, to sound a bell when the temperature rises. So this is the most suitable option for the type of circuit that we have seen. Is that okay? For the type of circuit we've seen. We go to the next one. We say, the diagram shows two voltmeter P and Q connected to a potential divider. This is two voltmeter, this voltmeter P and this voltmeter Q connected to a potential divider. Now the sliding connection at point X is moved towards the top of the diagram. So we're going to move this one to the top of the diagram. So if you move it to the top of the diagram, what happens to the resistance? What will happen to the resistance of at the top? The reading of P. What will be the voltage on P? The resistance will reduce. So this one, the voltage will also reduce here. So voltage will decrease at P, but on Q, voltage will increase. Okay, so that's B. That's B. If we move this variable resistor up, if we move this one up, this connecting contact, slide it up, the voltage output, the voltage measurement here will decrease, will be lower, will be smaller, will decrease because you move this one up, and the voltage output at Q will increase, will be bigger, will increase. Okay, so that's that for this circuit. We'll move to the next question. Okay, so all these questions are there for just to try you. Don't panic in any exam. When you panic, you fail. Okay, when you panic, you start failing. Now I say this topic we're going to cover in the fewest moment. We're going to cover this logic gate. It's called the logic gate. We're going to make a video for the logic gate. Okay. Now the diagram represents a digital circuit using a NOR gate and an AND gate. NOR. Why is it NOR? Because of this circle here. Otherwise, if there was no this circle here, this would have been an OR gate. An OR gate. Okay. So now we're going to feed the information, input. We start from 0, 0. So if here is 0, here is 0. Normally in OR gate, 0, 0 is 0. 0, 0 in OR gate is 0. But in a NOR gate, it will be the opposite. So here will be 1. So if here is 0, 1 and 0 goes to an AND gate, it will be 0. It will be 0. So if you look at the output of all of them, the ones that are 0 are the ones that we consider. C and D, they are wrong already. C and D are wrong because the first output is supposed to be 0. The first output is supposed to be 0. But they have their first output to be 1. So C and D already out of the race. Now we go for the second challenge, second contest. We feed input 0, 0, 1. Okay, all of them is same input that we're feeding. 0, 0, 1. So here is 0, here is 0. We get 1 here because it's a NOR gate. If it's all gate, that will be 0. We get 1 here. And then 1 go here. What we get, 1 and 1 go to an AND gate, we get 1 at the output. We get 1. And so anyone, the second one, if it's not 1, is wrong. So this one is 0. This one is 1. So this is the correct answer. So we go for this. This is the correct answer. Okay? If you've not done logic gate at all before, you may, what we are doing looks surprising or looks, but it's very easy exercise. Okay? We're going to like have a section in this week, or probably this week we're going to have a section explaining logic gate video for A level and for A level and 100 level and IGCSE. Now, which statement about electromagnetic induction is correct? Which statement about electromagnetic induction is correct? Which statement about electromagnetic induction is correct? A strong magnet that is held by stationary near a stationary conductor causes a greater effect than a weaker magnet. Causes a greater effect than a weak magnet? No. The effect occurs when a magnet, the effect occurs when a magnet and a conductor are both moved with the same speed and in the same direction. So B, no, right? B, no, right? C, the effect occurs when a magnet is moved away from a nearby conductor. Say which statement about electromagnetic induction is correct? The effect occurs when the magnet is moved away from the nearby conductor. The effect occurs only when a magnet is moved towards a conductor. Not only. This D, it would have be correct, like almost like C, but it say only. It's not only. It's when either you move it towards a conductor, or you move it away from conductor. That's when the effect happens. So it's C. Okay, so that's C. So we move to the next one. The diagram shows a current carrying conductor in a magnetic field. Which row shows the direction of the force acting on the conductor? Which row shows the direction of the force? Current is moving like this. See, direction of the current is this way. Current is moving like this. It's going like this, going like this. Because this is the positive arm of the battery. So current moves like this. Conventional current goes like this, okay? Normally, ideally, if current is going up, the force is supposed to, current is going up, right? Force is to go down, right? Force is to go down, ideally. But remember, the polarity of the battery, usually in such scenario, we always put north pole here of the magnet and south pole here, okay? But in this question, they twisted it, they changed the north pole. It's like if you turn this computer upside down, you will get the normal scenario that we used to do. You get the normal scenario that we used to do. But right now, they twist the polarity of the magnet. Normally, north pole used to be here, you know. Normally, north pole used to be here, right? And then south pole is here. And then when current goes up like this, when current goes up, we would have said that the force will go down. We would have said the force will go down. We would have said the force will go down, right? However, they've twisted the polarity. They've changed the polarity of the battery, of the magnet. So that's not going to be the case. So since the polarity changed, then the force will go up. Since the polarity has been twisted, instead of the force going down, the force will go up. So the answer is A. The answer will be A. The answer will be A. So we'll move to the next question. Now, power losses in transmission cable are reduced by increasing the transmission voltage. Okay? Power losses in transmission cable are reduced by increasing the transmission voltage. Yeah, I think we have a video on this. Power losses in transmission cable are reduced by increasing the transmission voltage. Right? Now, what is the explanation for this reduction? Say power losses in transmission cable are reduced. So power loss, if you want to reduce your power being lost, you increase the transmission voltage. We step up the voltage. We measure this. We measured this before. Okay? We've measured this before. You have to increase the transmission, step up the voltage to a big value, to 440,000 volts, in order to reduce the loss in transmission. Okay? Okay. Okay, so what is the explanation? We say the current decreases, reduces the thermal energy loss. Yes, when you increase this, the current will decrease. The current will decrease. So when you step up the voltage, the current will decrease, okay? When you step up the voltage, the current will decrease, right? The current will decrease because R, we said R is what? V over I. This is not Z, this is equal to, okay? V over I. When you step up the voltage, the current will decrease. When you step up the voltage, the current will decrease. Okay, so the current decreases, reduce thermal energy loss. And once current reduce, once you increase voltage, current will reduce. Once current reduce, your loss of energy will reduce also. So A is very correct. Current increases the flow of charge. No. Why we step up voltage not to increase current? The resistance of the cable increases, reduces the current. Resistance of the cable increases, reduces the current. No. And the resistance of the cable decreases. No. So the best option is option A, as we've chosen. The best option is option A. Now let's go to question 10. We're almost rounding up this paper. Let's go to question 37. We say in an atomic model, an atom consists of a central mass. This central mass is called the nucleus. We know this, right? The central mass orbited by a much smaller particle. Well, the orbiting particle is electron. Electron is orbiting the nucleus, okay? That's what atomic structure taught us. That's what we learned from the atomic theory. Okay, now what is the name of the central mass and the orbiting particle? Oh, we've already mentioned this. The name of the central mass, this one is the nucleus. Nucleus. Not neutron, nucleus. So anyone that does not, so the answer is between this and this. Nucleus. And is electron. Orbiting one is electron, so the answer is D. The orbiting one is electron. Nucleus for the central mass. This one is the nucleus. And what is moving around it is the electron. Electron. Is that okay? So all this small revision you have to like brace up for all of these things to come. They're not difficult, but you have to like be looking at your work very intermittently. Is that okay? Now let's take a look at this. It's a nuclear fusion. It's a reaction that takes place in the star. Fusion is the joining together. Fission is splitting. Fusion is joining together of two atoms, two smaller atoms to make a larger nucleus. A larger nucleus. Two smaller nuclei to make a larger one. That's a new fusion. Okay, which will describe the reaction. So the action of the atomic nuclei and the energy. Is the atomic nuclei split. Anything split is wrong. Fission is split. Fusion is joined together. So A and B are wrong. Just focus on C and D, choosing your answer. Atomic nuclei join together to form a larger nucleus. Yes. Energy is absorbed. No, energy is released. Energy is released. Whenever this happens, energy is released. So D is the most correct answer. Okay. So we go to the next one. You see, the diagram shows emissions of from a source passing into the electric field between two charged plates. You have the positive plate and the negative plate. Now, this is a source, a radioactive source. This is a radioactive source. Now, this radioactive source, okay, in this radioactive source, it emits particles. It emits some particles, which are usually, we call the radiation particle. Now, the one that remains or deviated, that passes, doesn't deflect to the positive, neither does it deflect to the negative. It's called the gamma ray. It's called the gamma ray. Okay, it's called the gamma ray. This straight one is called the gamma ray. The one that deflected to the negative plate is called the alpha. It's called the alpha. This is the symbol of alpha. It's called the alpha particle. Alpha is not called a ray, it's called a particle. Alpha and beta, they are called particle. Only gamma we call a ray. Okay? This is called alpha particle. Alpha particle. So this, why is it that the one that deflects to negative plate is alpha? Because alpha particle is a positive charge atom. It's a positive charge. Only positive charge will be deflected to negative. Okay? If it was deflected to the positive, it's a beta. Because beta is negative, fast-moving electron. So, and it's the one that will be deflected to the positive. But since this one is deflected to the negative, it's an alpha particle. So let's look. You say, what is emitted by the source? Neutrons and gamma ray only? No, no neutron. Alpha particle and beta particle only? No. Alpha particle and gamma ray only? Alpha particle and gamma ray only? Beta and gamma? No. So the answer is C. In this regard, alpha particle and gamma ray only. So this one is the choice for us. Now we go to the last but not the least question. The last but not the least question. To finish this paper, we say the graph shows how the count rate registered by a counter near to a sample of radioactive isotope changes over a period of a few days. And the background count is 5 counts per minute. The background count is 5 counts per minute. Okay. The background count is 5 counts per minute. Okay. Okay. So, what is the half-life of the isotope? Now we add the background count. So, you know, here is 45, right? The radioactive source starts from 45 here. So when we add the background count, we get 50. So we now assume it starts from 50. So to get half-life, you say 50 divided by 2. To get half-life, you say 50 divided by 2. Okay, remember there's background count of 5. 5 counts per minute. Okay, so 50 divided by 2, we get 25, right? 50 divided by 2, we get 25. Now we go to, on the count side, we go to trace it to the minute side. So here's 25 here, right? We trace 25 here, because the answer is 25 for counts, right? 50 divided by 2 for half-life, 25. So come here, 25, trace it to the graph, and then trace it down. Okay, 2 days. It's 2 days. The time is in days. The unit of time is day. So the half-life is 2 days. The half-life is what? 2 days. The half-life is 2 days. Okay, how did we get that? Because here the radioactive source starts from 45, but there is background counts that is added to it. 5 plus 45, you get 50. 50. If you're looking for half-life, you divide the count by 2. So if you divide 50 by 2, you get 25. You get 25 counts. So you come here where 25 is. You come here where 25 is. You trace it to the graph. Trace it to the graph and then trace it down. You get 2 days. 2 days. So let's go for the option of 2 days. Yes, A, 2 days. So A is our answer. A is our answer. 2 days is the option. Okay? So the answer to this question is 2 days. So this is it. This is what it is. So today we come to the end of this paper. Thank you for joining Waidsum Academy.